Assalamualaikum and hi everyone. So this is the lecture note number 2 for chapter 1 geotechnical engineering. So the first chapter we will talk about two-dimensional flow in soil. So when we are talking about two-dimensional, it refers to the seepage that taking place around sheet pilings or any other water returning structures including dam. Okay, so for the beginning, we will go through for the homogeneous and isotropic soil mass. So what is homogeneous and isotropic soil mass? It's actually assumption that we made that the soil mass have all kind of the same materials within the soil mass and also have the same stresses in all directions of the soil mass. Then we will use the flow net to determine, to study, to evaluate about the seepage. So the learning outcome for this topic is to understand the definitions of seepage, to understand the use of flow net, able to draw the flow nets below the concrete dams, the sheet pile and even through the earth dams, and then from the flow net we will calculate or determine the seepage stresses, the pore water pressure distributions, uplift forces and also the hydraulic gradient. So before we go further about seepage, this is just a recap for the 1D flow of water within the soil. So why we need to know the principle of the fluid flow? Because for the engineers it is very important, especially we want to solve a problem that involving the rate of which water flow through soil, meaning that we need to determine the rates of leakage through the earth dam. Okay, how the amount of water that infiltrate or leakage through the earth dam. And also normally when we deal with the compressions, for example, we need to determine the rate of the settlement of the foundations. And also when we are discussing about the strength of the soil, when we are talking about strength of soil, we need to consider the content of water, the flow of water within the soil mass, in order to evaluate the factor of safety for the embankment or the slope stability. Alright, again this is the recap for the 1D flow of water through soil. If you can see here that the water can flow from the higher levels of water, from the upstream, okay, to the downstream, to the lower level. If you can see here that the level of water, okay, this is the higher level at the right side compared to the left side. So water will flow from the right side to the left side, and this one is obviously, okay, from the top to the bottom, right? And then also if you can see here, right, the flow of water within a soil mass, okay, with the different elevation, okay, with the different elevations, so we will have the delta H different in head loss. Okay, and then from the Darcy's law, okay, from the Darcy's law, that the velocity V equal to Ki, alright, with the Q, the quantity of flow, the quantity of water, okay, will equal to the velocity and also the area, the cross-section area of the soil. Alright, and then when we substitute Ki, V with the Ki and A, you will have Q equal to Kia. And what is II is the hydraulic gradient. What is the hydraulic gradient? Is the gradient, okay, along the length path of the flow, okay, and also due to the head difference between the water level. Okay, and then you can calculate the Q equal to K H over L times dengan A. So this is from the Darcy's law. Okay, so again, that water can flow from point A to B, but we cannot assume that the water flow in a straight line. Basically, the water will find the pores, will find the voids for it to flow within the soil mass. Okay, if you can remember the terms of permeability, that refers to the how is that water can flow within the different kind of soil. For example, if you compare the clay soil with the gravel size of soil, which one will have the higher permeability? So obviously the gravel will have higher permeability, because compared to clay, gravel have more pores or voids, so water can easily flow within the particles of soil.